Hello, friends. My name is Will, and I am going to be talking with you about machine learning. We're going to explore artificial intelligence, machine learning, and specifically, we're going to look at kind of putting the puzzle pieces together to make machine learning actually useful. I think we do a lot of workshops, especially at MLH, but everywhere on like, here is kind of a specific machine learning idea, or here's how, like this one API. We talk a little bit less about kind of how you assemble machine learning into a single thing. It's actually helpful. So that's what we're going to talk about today. We'll probably wait until a few minutes after the hour to really get going. So come on in, hang out. It'll be pretty informal. But it'll be a good time. And I'm excited that you're here. There will be a little bit of a hands-on portion to this little live stream workshop, but you have no obligation to do it. In fact, actually, my goal was to have Quick Lab credits for everybody, or Quick Lab tokens. I'm an engineer at Google, and so I was going to ask the person. And they did not get back to me in time, and so I don't have Quick Labs credits for everybody. But there is another way we can do it. It's just a little bit hacky, but yeah. Oh my goodness, Adam, Hannah, it's so good to see y'all. Yes, the flower crown is back. It wouldn't be for me. It wouldn't be a local hack day if I wasn't wearing a flower crown a little bit. We got the flower crown. We have Treasure Map Goose hanging out with us. The treasure map is still secret. And we have Adam and Hannah, a killer combo, if I do say so myself. And my house, actually, okay, so this is sad. I think I told you, I recently moved, and it's new construction, and so it didn't have internet things hooked up, and so it was a while. Or I wasn't able to get internet set up, and I was stressed about it. And I still don't actually, but my neighbor, her name is Sally. She's really, really cool, and she gave me her Wi-Fi password. So, so that's how I'm getting to you via her Wi-Fi through the wall. But yeah, we do stand Sally. Sally's the best. I'll have to let her know that I name dropped her. Don't harass Sally, y'all. That would be very rude and against the code of conduct. Local hack day after shark. Oh my goodness, yes. I'm gonna have to go back to IKEA to see if I can get a shark again. But let's see. We're talking about machine learning. Here's my big poll question. Do you use, obviously we talk about these terms and they're different, but they have slightly different connotations, but sometimes people use them interchangeably. Are you more likely to use the word artificial intelligence or machine learning? Which one do you go for? This is my poll question for you. Answer in the comments. I'll go ahead and just bias it right off the bat and say that I am more likely to use the word machine learning. Boom. Adam says smart computer. AI. Yep. Cool. Let me know. I'm curious kind of what the distribution is. Obviously, they do have kind of different definitions. I think AI is a more general thing. Oh, Adam, you're so good. Okay, yes, Adam has just dropped the link. If you are here, but you have not checked in, please do so. Both because it helps us keep track, but also because it's what you need to do to win the points for your guild, right? That's right. That's how guilds work. Hannah says ML. My understanding, and we talked about this, I think, earlier today. We talked about how AI really is, this is a couple days ago, but AI is really just any time a computer does something that seems smart. And then machine learning has this very specific technical definition. Let's see, when in reference to coding, making one machine learning, but to a non-techie AI. I think to be fair, I think that's probably actually what I really do. If I'm talking to someone that probably doesn't know the term machine learning, I'll say AI. Otherwise, I'll probably use machine learning. But yeah, I think kind of the more technical of a space you're in, I think maybe you use machine learning more. But you can use either during this workshop. This is not going to be a case where we tell you to use one word or the other. But it's really going to be a case where we talk about kind of some general rules and how we glue some stuff together. And And I think I said this earlier. Actually, I guess we're 6 minutes after the hour. We'll kind of get started. My name is Will. I am a coach at Major League Hacking. I'm full-time a software engineer at Google. I am an espresso enthusiast, as hopefully some of you saw earlier today, if you joined us for the Hacker Espresso event. But I also really into machine learning and artificial intelligence. And this is an experience that I had, and I think that a lot of people have had this experience, is the experience of seeing a lot of tutorials and workshops and even some live streams that are kind of showing you how to do a very specific thing with machine learning, but not actually telling you how to fit all the pieces together to like make an actual useful app or website that actually makes use of machine learning. And this was for me like this big chasm. It's like, okay, I like know how to call this Python function that will give me back a prediction based on the data I give it, but I don't actually know like how to build something that's going to help somebody. And that was kind of what I thought we could make a topic of this about. There is still going to be a short kind of hands-on section at the end here. Mostly it's going to be us just chatting. That hands-on section, it was going to be more elegant. There's this platform called Quick Labs that basically lets you use Google resources for free, but you have to have tokens to do it. And I work at Google, and so I asked the person, like, hey, can I have some tokens to do this thing? And I asked them that on Friday, and they did not get back to me in time. So that's on me. That's totally on me. But because I don't have the tokens, we're gonna figure out another way to do it where you won't have to pay any money, but it will be a little bit less ideal. So we're mostly just gonna talk and kind of look through some examples of stuff. Let's see. Adam says, if there was a first-party coffee hacks, would you work at Will? Yeah, I would. I would work coffee hacks. I would come out of my event retirement and do coffee hacks. And technically, it's a different. Quick Labs technically uses a different credit system. They're related. Our workaround is just going to be that if you haven't already, signing up for the Google Cloud educational credits, and we're just going to do it kind of off-label. But we'll follow along with this lab later. But that's later, and this is now. We're having a good time together, and I'm very glad that you're all here. We already weighed in. I think some people say AI, some people say machine learning. A lot of people are like, depending on who I'm talking to. That's kind of an interesting insight to get into how we all use these words. But now I'm actually curious. I would love to get a read on, like, type something in the chat if you have ever gone to any workshop, done any tutorial, or in any other way kind of like done an educational thing for machine learning. So if you've ever done a tutorial, read an article, gone to a workshop, watched a live stream, I want to know if you've done that. And then separately, I want to know if you have ever actually like built an app that has used machine learning. Because I'm curious to see, I mean, like I was in the position where I had done a lot of the first thing and I had done very little of the second thing. So I'm curious, like, if people have thoughts or experiences on that. I'm generally interested, because that's kind of where we're going to dive into today. Adam, for the record, I had the check-in page pulled up and I was ready to drop the link, and you're just faster than I was. You're just so good at posting the link. So, I want to actually start with, I have like 4 big like topics or lessons that I feel like I have picked up when it comes to putting the pieces together when it comes to AI. And the first kind of big one. Okay, so sorry, I'm just checking the comments again. It seems like there are some folks that really have used that AI and machine learning in context in a project, but there definitely are some folks that like have learned about it but have kind of not made that leap to actually like implementing something that uses it. So that's good kind of mix of folks. So we got kind of four big little pit stops we're going to make. And the artificial intelligence from the old world order is religion, its memes are dangerous. That's really funny. Good comment. I'm going to put that up there. Yeah, lesson number 1, or kind of idea number 1, is that you don't always actually want machine learning. Machine learning is not always actually the solution to your problem. And yes, people actually watch on Facebook occasionally, Adam, apparently. Oh yeah, welcome to people from all platforms, not just the Twitch streamers. So I was actually talking to someone a while back. I was interning at this kind of public startup accelerator, and there's a guy that I was working with there who was really, really intelligent. And I actually ended up working with him on this project called Math Leap. And it was it was a cool help kids learn math, learn algebra kind of thing. But someone else was coming to him. He had worked at Google at the time, and someone was asking him this question, and they were kind of pitching him their idea. And if you have any tech background, you probably have had this experience of someone coming up to you and saying, "Hey, I have this idea. It's like Uber for Snapchat for dogs, only it's purple." And you're just like, whoa, okay, you should go do that, but I'm not interested. Actually, let me know in the comments if you've ever had someone pitch you on their app and you're like, this is not for me, because that's happened to me. But this is what was happening at the Startup Accelerator, and my friend was kind of listening to someone tell them what they wanted, right? And they said, I really want this way of using machine learning and having users be able to enter in their interests, and then getting a list of all the users that have shared interests, that entered the same interest. And he looks at the guy and he says, "I'm sorry, friend, you don't want machine learning. You want a database, right? What you're describing is just a SQL database." And I thought it was just so funny. To be fair, I totally lost my crap, but yeah, exactly. I can handle the business side. Or my other favorite one is I'm more of an ideas guy, and you can handle the implementation. Big red flags. We should do one of those red flag memes. Anyway, I thought this was a really funny moment because it was really true. And if you've ever used a SQL database, having people enter in a list of things they're interested in, and then just being able to select, okay, these are all the users that all are into the same thing. That's 2 lines of SQL, right? That's a very simple kind of solved problem. And you don't need to use machine learning for that. I don't even know what machine learning algorithm you would use. I mean, you could think of applications, but this is one of my big things that I think it's good to put out there is you don't always need machine learning. It can be sexy, it can be fun, and it can be fun to try to throw machine learning at things that don't really need it just for the learning opportunity. But if you are actually trying to get stuff done, I think that you should really look in the mirror and say, what do I think machine learning is actually here to do? And there's a lot of cutting edge machine learning research, and there are a lot of really good thinkers about how to use machine learning in kind of clever and novel ways. But largely, I think that there are 2 big camps where machine learning is actually helpful and you can use it. And for folks that are familiar, you might know what I'm going to say, and that is unsupervised learning and supervised learning. And I think it's helpful to throw out these paradigms just so you can kind of think, oh, is this a case where I really should be using machine learning, or is this just a database, right? So supervised learning is basically you have a bunch of questions and answers. I'm not talking about reinforcement learning. We're not doing that. Okay, another day. Because depending on how you think about it, reinforcement learning could just be called a different kind of supervised learning, because you're supervising the reinforcement happening. I don't know. We could talk about it. We could talk about reinforcement learning. It's kind of like the redheaded stepchild of the machine learning world. It's really cool though. I like it. I digress. Supervised learning is when you have a bunch of questions and answers, and you already have all of the answers, right? So, for example, if my question is is this a picture of a dog or a cat? If I have a bunch of pictures of dogs that say dog next to them, and I have a bunch of pictures of cats and they say cat next to them, then that's a supervised or a labeled data set that I could use supervised learning on, right? I take all those images of cats and dogs, I feed them into my algorithm, and then I could ask it questions in the future. I can say, hey, I have a photo of a cat. Or I have a photo. Tell me if it's a cat or a dog or neither, right? You can think of a lot of other examples where you have some labeled data. This is kind of the key word, is do you have labels on your data? So I just moved into this new house and I spent a lot of time on Zillow, right? And one of the big things that Zillow does is try to predict how much a house is worth. And this is a really good example where if you look at the past, we have a bunch of houses, we have data on the house, and we know how much they actually end up selling for. And so you actually have that data, you have questions and answers, and you could feed them all into your model, train your model, and then show it a new house that hasn't been sold yet and ask, hey, how much do you think this is going to sell for, right? This is kind of our one big category. And honestly, like if I look at actual applications of machine learning in practice, this is like 90% of the actually useful machine learning out there is we have some data and we want to use it to make predictions, right? That's one. The other kind of cluster of machine learning, pun intended, is unsupervised learning that we're going to briefly chat about. And it's a little bit trickier. So unsupervised learning is basically when you want to discover some kind of structure within your data, but you don't have any labels. And for our purposes, because we're not doing sort of graduate level unsupervised learning, it's really going to come down to a single concept that can be used in different ways, and that is called clustering. And the idea of clustering is just saying, maybe I have a list of 1,000 customers, or I have a list of 30 different dog breeds and a bunch of data about those different customers or different dog breeds. And I just want to know what kinds of groups would I put these in, right? This is like if you're like just trying to segment your data, you're trying to say, well, what are the right groups to put these in? And you don't already have groups. You can use clustering algorithms, which are thought of as unsupervised machine learning, to just look at all the data and kind of try to draw circles around these groups, right? Anyway, I spent a moment just kind of giving you the basic description of supervised learning, where you have labeled data and you want to make predictions about unlabeled data. And for our purposes, clustering algorithms that are unsupervised learning. And there are other kinds of machine learning. There's other kinds of unsupervised machine learning. Someone mentioned reinforcement learning, where it's basically if you can construct an environment or a game for your agent to like play around and learn in. There are other things, but I think if you are not trying to cluster things and you are not trying to predict things from labeled data, if you're not doing one of those things, it is likely that that machine learning is not your answer, right? And that's like I want you to take that with a grain of salt, because there are lots of creative ways to use machine learning, and do not shy away from really trying new things. But I think if someone comes to you with an idea and they say, hey, I want to use machine learning in order to in order to do Uber for Snapchat for dogs, but it's purple, kind of ask yourself, okay, what predictions are we trying to make? Or what things are we clustering? And if it's not one of those things, then you should really ask them, like, well, how do you think we're going to use machine learning? And of course, the grain of salt that there are other things out there, and that's not, it's not that all machine learning is predicting or clustering, but a lot of it is. Let's see, what would a me in Smash be? Are you asking what a me would be unsupervised or supervised learning? I'm not sure what that question means, but I feel like it's probably funny. Let's see. What would a me? I mean, so there's the thing where you can like submit a photo and it will try to match features to your photo, right? And like generate a me. And that's like a case where actually I think there probably is, some machine learning at play. And I would call that supervised machine learning, because I would bet what they did is they had a bunch of individuals at Nintendo, at the company. They said, here are a bunch of photos of people, and we want you to create their me's, right? And they had a bunch of people look at the original thing and then go and label the data, or sorry, go create the me. And the me is, you render it as this kind of cute little visual, but it could have just been, a JSON object that says, like eye type, and then the type of eye, and eye color, and the color of eye, and eye size, and the size of the eye, and eye placement, and the coordinates of where the eye should be, right? And so then they would have actually had a lot of labeled data. So this would be supervised learning, where you have kind of previous labeled data of pictures of people, and then the me's that created them, or they created, and then you can generate new me's from new photos. Oh, I see what you're talking about. Yeah, I'm a little bit less familiar with like the models of characters that you can train on, and so I will have to. If you want to explain more about it, I could weigh in, but I think you're probably right based on what you're describing. But yeah, if you want to get more details, we can chat more about it. But yeah, so this is kind of lesson one: is don't always assume that machine learning is your answer. I think Hannah had a good quip. Let's not throw tech at everything. Yeah, like sometimes what you're looking for is the old stuff. Sometimes what you want is just a database, or just a Python script or whatever. So this is another big one that I want to throw out, and this is actually really good that we touched on, like this example of Mies, at least kind of like the old school sort of take a photo and turn it into a character. Where Nintendo probably hired people to go and look at a bunch of photos and generate Miis they thought looked correct, right? And the key here is that Nintendo had to probably spend, like, I would guess, on the order of magnitude of like tens of thousands, if not hundreds of thousands of dollars, just to literally hire those people to generate data for them, right? And I don't know about y'all, but I don't have hundreds of thousands of dollars lying around to go spend on data creation. And so I think a really good thing to think about when you're going into actually trying to solve a problem with machine learning is to be realistic about what data you have access to, right? Because if you're doing either the supervised or the unsupervised, the definition of machine learning is that the more data you have, the better your model actually performs. And so if you need to go out and generate your own data, sometimes that can be really, really cool and beneficial, but often that can really be limiting to what you're able to do. One resource that I'm going to throw out here is Kaggle. Disclaimer, I think Kaggle is technically owned by Google. I think Google bought it. So, I don't know, conflict of interest or whatever. But like, hey, I tell you all the Google stuff all the time, and that's not, I don't know, get over it. Adam says, I look like the Snapchat filter from, oh yeah, I remember that one. Yeah, I love that one. That was my vibe. I think that's probably why I bought this flower crown. And then not Gilgamesh, you fight them and they improve based on how well they do. They learn from playing and can perform on a pro level, similar to an AI chess machine. Oh yeah, so this is a great example. So I'll show you Kaggle in a second, but this is a great example to talk about. And this is exactly what I was talking about when it comes to the difference between, or the similarities between, reinforcement learning and supervised learning. So supervised learning is the idea that you have labeled data and you're able to train from that labeled data to kind of make better predictions in the future, right? And what reinforcement learning is really a kind of supervised learning, the key being that the model actually generates its own data. So, for example, playing chess, one really cool thing you can do is you can create a chess AI, and then you can literally make two of them and have them play chess against each other. And just by them playing against each other again and again and again, the first game, one of them will win, and they'll be able to look at all of their actions they took and basically label those as, hey, these actions were good enough for me to win. And then the one that lost will be able to look at all of its actions and say, all of these actions were bad enough that I lost. And so the models played the game, but on some level, that was creating some labeled data. And ultimately, that means that you can go back and do what we call supervised learning. The only difference is that the model is actually participating and generating its own data. So cases where you're trying to build like AI opponents, or you're trying to do, actually, I think it was on Thursday or Friday, we did a workshop where we basically built this kind of AI for rock, paper, scissors. And what it literally did was it played against the human, it played against you. And whenever it won, it was like, okay, what can I learn from winning against Will? And it might be that I play rock too often, or it might be that I follow paper with rock, or whatever, and learn stuff. And then if it loses, it'll similarly be like, okay, this influences things. What can I learn from this? And it will label what it did basically as a failure, right? And so basically what you do after that is you just have all your labeled data and you say, I just want to predict success, right? Like, what would I have to do in order to predict success here? And that's a little bit of an oversimplification, but that's kind of the bones of how reinforcement learning is quite related to supervised learning, with some caveats. Does it still exist in Snapchat today? Honestly, I don't know. Unfortunately, I am not W. Lifford on Snapchat, and my username is kind of cringy, so I'm not going to share it on this stream. And it's not like that cringy. It's just kind of silly. Not Gilgamesh. I'm really glad that that made sense and that was cool. Yeah, thank you for raising that question. It was a great one. And hey, we touched on reinforcement learning too. So that was lesson number 1. To recap, was don't always assume that machine learning is the answer to your problem. Sometimes it is, and that's great. But sometimes all you need is a SQL database. So idea number 2. Oh, wow, someone's already W. Lifford on Snapchat, and it's not me, Whitney Lifford. Dang, Whitney. She's probably my cousin, or he's probably my cousin. I don't know. They're probably my cousin. But lesson number 2 is the idea that you really should be realistic about what data you can get. Reinforcement learning is actually a great example here because if you can program up the game, then you can get all the data you need, right? You don't need any data on chess games in order to make 2 AI chess bots play against each other. So that's actually could be a really, really neat sort of out if you want to do reinforcement learning. But if you're looking to do unsupervised or supervised learning, for example, if you want to build a model to predict how much a house is going to sell for, you need a lot of real estate data, right? Like a lot in order for your model to be good. And if you don't have access to that, then you're kind of in trouble, right? The ability of your model to really be successful or really be kind of high accuracy is really limited. And so what I'll throw in here is sharing my screen. Boom. I'm aggressively not doing any slides for this because last time I tried to use slides, it was a disaster. So this is Kaggle. My disclaimer from earlier stands. I work for Google. I think Google technically owns Kaggle. You know, I'm not being a shill right now. I just think Kaggle is cool. But you have to create an account. But then what you get access to, it's totally free, and you get access to a bunch of cool data sets. So, for example, if we wanted to predict housing prices, we could literally just look up, you know, housing prices. And I'll think about it for a second. And look at this. We have a bunch of cool, interesting data sets. We've got California housing prices. We've got even one that's like about, oh, these are challenges. So the big thing that Kaggle is known for is doing competitions where everybody tries to build a model based on the same data, and whoever builds the best model wins. And sometimes you can win like prizes, you can win money and stuff. So it's cool if you want to take a crack at that. But the thing that I looked at Kaggle for by far is just all the cool data. Zillow house price data, that could be a cool one. And you can come in here and you can actually see, you can get some summary statistics, but you can literally just download a CSV of all the different things. So you have the GPS coordinates, you have latitude and longitude, you have the housing, what does this say? Housing median age. So this is the median age of a house within a block. So I guess you can kind of tell if the neighborhood is newer, if the neighborhood is older. You scroll along here, total bedrooms, total rooms, total bedrooms, population of that area, number of households in that area, which I guess would kind of give you population density. And then you have at the very end here, median house value. And this is how much that house sold for, right? And so you could take this and you could just really push this into a model and get a pretty good, at least for the parameters of this being in California, which is always the key, is if your data is relevant to a particular place, if all your data is from California, your model will probably work well on California and probably nowhere else. Or it will probably be very, very limited in what it can predict in other places. Here's one from Zillow. And this is cool because you see just how much data. That's, I think sometimes we get, it's hard to compare different data sizes of different types, right? So like 300 megabytes for photos is like maybe a couple photos. For a video, that's like maybe like a minute or 30 seconds of video. But for data like this, where it's mostly numbers and text, 350 megabytes is like a ton of data. And so that's like a could be a really cool data set to use. So this is Zillow, and this is kind of a sub point on this point about be realistic about what data you actually have access to. Another thing that I'll throw out actually is something that was kind of fun that I did a while ago. And while in some ways this is not really advisable, like people who are actually scientists out there will be like, Will, why would you do that? But I remember a few years ago, I was running a machine learning club at the University of Tennessee, where I went to school. And fake news, it was like the first time that everybody was talking about fake news, kind of in politics and in media. And I really, really wanted to do a Kaggle challenge where the goal was to be able to just look at a piece of news and be able to say, hey, is this reliable or not, right? And no such data set existed. But what I could find was a data set that was just of a bunch of reputable news articles. So it was like news articles from like the top 10 publications in the US or whatever. And then there was a separate data set that was like, it was like articles from websites that had been marked as spam, right? So it was these two different data sets, and each of them was very clearly, one of them was very high quality and one of them was very low quality. And so what I did is I literally just merged those two data sets together and then did a few things to kind of anonymize them. And that was our kind of meta data set for trying to predict if something was quote unquote fake news. Again, there are a lot of issues with doing that. I think if I was like actually trying to publish a paper or was doing this for an employer or something, there would have been a lot of caveats because there are lots of differences that you can't really account for between those two data sets. But for the project that I was doing, where we just kind of wanted to get a general sense of things, it was really cool, and it was a really nice way of making the data that I needed for the task that I wanted to do. So Kaggle is a great resource to find data sets. I'm curious, actually, does anybody have if you want to drop in the comments, any other great places to get data? I know that actually like NASA puts out a decent amount of data, like geospatial data. Are there any other like really great treasure troves for data on the internet? Actually, speaking of the internet, one of the best treasure troves for data on the internet is literally the internet, right? Every single web page has data on it. Like by definition, if it doesn't have data on it, it's not a web page. And there are lots of clever ways to make sort of the internet your data set. Let's see. Oh yeah, Hannah's going to hook us up with a really good GitHub repo that has links to good data sets. There was a torrent site with data sets for education. Oh, nice. GitHub, awesome data. Awesome public data sets. I love that. Okay, so on the topic of, you can do stats for nerds on your favorite YouTube. That's cool. Let's go to you. Is that like stats for nerds? How to use YouTube stats for nerds. Oh, cute. Now let's see, GitHub. Awesome data. Awesome data. And then awesome public data sets. Nice. Oh, this is a treasure trove. We got physics, we got prostate cancer, we got search engines, sports. Nice. Okay, so this was already on Twitch, but I'll post it as a comment again. The problem, Adam's calling me out for using light mode on GitHub. The problem is that I almost, like these days, rarely use GitHub. I use a bunch of internal Google version control systems, and they are all in dark mode. But yeah, I don't really use GitHub that much. But yeah, I'm a fan of dark mode. I think it's on average better. I think it's actually technically better for the environment too, because computers showing things in dark mode actually use less power. Fun fact. Cool. So lots of cool places to get data, but ultimately your the strength of what you want to do is going to be limited by the strength of the data you can collect. Actually, one more story on this topic was when I was in college. I actually for a short period of time, I was a columnist at my school newspaper. And the whole my whole pitch was I was going to do some kind of data, like investigative data journalism kind of thing. And there was one week that I was like, I want to explore the pig tax, and I want to go collect some data on the prices of things. And so what I did was there were way better ways of doing this, but I literally went down to Walmart and I went and I counted every single the price, or I recorded the price of every single thing of deodorant. And then I recorded if it was clearly gendered and targeted towards men or women, or not targeted towards any specific gender. And then I recorded the price. And then I actually watched as people went and came and picked up. And I just saw which things got purchased more, right? This was a terrible way of collecting data, but it was kind of fun. I wasn't actually trying to do any machine learning with it, which I think is the only reason that it was kind of okay. But manually collecting data is a drag and a hassle, and it can be a fun story. But if you can find the data online, which I'm sure there was data on the pig tax online, someone says GitHub has dark mode. Yeah, that's we're just talking about GitHub and dark mode. Also, to be clear, I know that GitHub has a dark mode. It's not turned on mine. Cool. That was kind of big idea number 2, was being realistic about the data you have. Big idea number 3, which I think is kind of the core of nominally what we're talking about here today, which is putting the pieces together. And that is the idea. I guess I can stop sharing my screen for a second, and I'll pop it back up in a second. But that is the idea that most machine learning problems can actually be broken down into smaller machine learning problems. And I think this is kind of a truism with programming in general, right? To know how to program is to if you want to solve a big problem, the first step is to try to break it down into tiny problems that you know how to solve. But I think this is sometimes harder for us when we're doing machine learning, because I think the idea we have in our heads is that there's a little bit of programming around the edges, and then there is the model that you can't really mess with because it's the model. You can't touch it or whatever. And the example that I'm going to throw out here to kind of discuss this is a personal. Oh yeah, thank you for telling me to unshare your comment, hide your comment. You are welcome. And so the little side project that I wanted to do, the motivation was that I read a lot of news articles, and after I finish reading them, I often feel I totally forget what I learned in that article, or what the article was even talking about. And so I had in my head, hey, wouldn't it be great if I had Duolingo for news articles? Also, I love how Duolingo for news articles really sounds like the fake idea of what was it, Uber for Snapchat for dogs, but it's purple. But Duolingo for news articles, it was a thought that I had. And my goal was you could enter a URL, and then you would get back a multiple choice quiz based on the article that you just read. And I did build this. It's actually kind of a little bit broken right now, but you can go to yogurt.click.com. Don't ask me why it's called that. But we can do a little demo time. And we're just going to use this kind of as an object lesson. No, yogurt.click. Oh, and it's not .com. It's just yogurt.click. I don't know why I said .com. Yogurt.click. And maybe if we all go onto it, it'll fall apart. Yeah, don't ask me why it's called yogurt. I was eating a lot of yogurt at the time. That's it. It's not that deep. Anyway, I just recently put in this article that was the bad art friend story. I'm not sure if anybody is familiar with this. I'm going to probably misquote it, but there was this real thing that happened where there were these this group of writers that was talking together, and one of the writers was had decided that they were going to donate their kidney to a stranger, and how it was like really, really important to them that that they didn't get any credit, and that they were going to just be a good person and give their kidney to someone that needed it, and kind of ask for nothing in return. And they were posting about this experience in this little group chat made for writers. And what happened was some of the other writers in this group chat said like really got fed up, and they thought that the first person that was donating their kidney was being all like morally superior or whatever, and they didn't like it. And one of them actually wrote a short story or series of short stories about their friend in the chat kind of making fun of them, but it was based on the idea of someone giving away their kidney and then acting morally superior about giving away their kidney. Anyway, the first friend then found this out and realized that this person was kind of taking her life experiences and kind of making fun of them in short story form, and so she sued the first or the second writer. This is kind of just like a people being wild on the internet story, but it's an article that I read, and so what I did was just enter the URL in here, and so you can click on it, and hey, we get a little quiz. And it's actually broken, so don't actually try to take the quiz. I mean, you can, but okay. Kolker's tale is one of aggression. Okay, we have a multiple choice question, and then that was right. More than a year later. Now, if you try to do the second question or later, it kind of falls apart. But you can do, let's look for another news article. Like, what about? Let's go to the Atlantic. They usually play nice. I'm not accounting stuff, the Atlantic. I just want like a random article. I guess I could also have done like Wikipedia or something. The best show on TV is Stuck. Okay. Oh, Succession. Does anybody watch Succession? I just watched the first episode last night. I thought it was kind of fun. Any Succession fans? Well, we could go back to the homepage. You didn't really need to. Oh, look, someone already did GitHub's guide to Hacktoberfest. Love that. You can search for this and quiz me. And okay, we have a quiz. You perhaps remember less about the specifics of each scene than the visceral feelings of tension. No, not tension. Of watching them. Gosh. Okay. So you can, you can mess up. So this is not me self-promoting. It's broken and it's not done and all the things. But this was like an idea that I wanted, and I kind of went about trying to go and build it. And so the question that I'm going to put to you is, how many different machine learning models does this make use of? And can you guess what any of them are? Or actually, I'll rephrase the question. It's not a yes or it's not a right or wrong question. But I am curious, if you were going to build this, how many different machine learning parts would there be, and what would they be? And I'm curious if anybody has any guesses. And then I will reveal the answer of what I actually did. Or if you don't want to guess, you don't have to. I guess there's also that's kind of a big question of how many models and what do you think the models are. Probably a lot to answer in a comment period, but if you are trying to answer it, it might take you a second. So I'll give a second. Actually, I know what I'll do. I'll pull out the kalimba. I'll do some kalimba music, and I'll play my one kalimba song. Thank you for telling me to stop screen sharing. Y'all, if I didn't have babysitters on the stream, I would be a disaster. Yes, it is the Avatar, The Last Airbender. It's the love theme, actually. It's the theme they use whenever people are in love. At least that's what I think it's called, the love theme. But yeah, I love that song. And I think it is originally performed on kalimba, which is neat. So I still see a disturbing lack of guesses. So I'll just go ahead and tell you the number of models and how many used, and that'll actually segue us into our kind of last point. And we might just make this kind of a short, casual stream. We might do, yeah, the kalimba is sleepy music. It's making me want to sleep. So maybe we'll make this a quick one. But for this project, I ended up doing, let me count my list, a total of 5 different models, making use of 5 different models. At least 5 different big ones. There were some smaller ones that I'm leaving out. But one of the big models was, given a URL, it's easy to download the web page, but actually picking out what is the actual like main text from that web page, that is like a whole model just to do that. And if you think about it, that's actually kind of necessary because not every web page is the same. A lot of web pages do use conventions, like with little body tags or little, like always putting the main text inside p tags or whatever. Maybe they have classes they use. But there's nothing actually standard. So if you want a comprehensive way of always getting the main text from an article, that requires some machine learning. And so that was kind of model number 1. Adam, I do want to learn a new song. Actually, I learned part of Smash Mouth, but I've forgotten it, and I don't actually, or not Smash. I've learned part of the song All Star by Smash Mouth, but I don't want to attack y'all with that song. But I'll learn a new song eventually. So model 1 was just literally getting the text. Model 2 was splitting that text up into sentences. This again, it might seem like, well, like can't you just do something simple like like the Python split function on periods? And you could, but that would actually break, right? Because sometimes you don't use periods. Sometimes you use exclamation points or question marks. And sometimes you use periods in places that are not the ends of sentences, right? Like if someone has an abbreviation, they might say, like I might abbreviate myself as W.L. As like those are my initials, right? And you wouldn't want to break it up into 2 different sentences where one sentence is just the letter W and one sentence is just the letter L. So this is another case where we're using machine learning. So a model just to get the main text from the article, another model just to split the text into sentences. Then there was a third model that its only job was to identify which sentences were quote unquote interesting. It doesn't do a perfect job of this, but the goal was to build these multiple choice questions just out of sentences that kind of had interesting stuff going on in them, right? So I would say like this sentence, the model doesn't do a great job on. The word watching is not great. But I mean, like, okay, 3, why season 2, read, why season 2 successful was so extraordinary. So this model we might say is not doing sort of like the best job. But you do need a model to pick like which sentences do you actually turn into questions, right? So that was model number 3, was picking interesting sentences. Model number 4 was finding quote unquote interesting words inside those sentences. So for example, you look at all these words and like none of them are like the word and or the word the or the word to, right? You don't have any of those sort of boring words. And I think it actually does an okay job of picking quote unquote interesting words, right? And so that was model number 4. And then finally, model number 5 was given a question where the input is both a sentence and the word that's being hidden as the answer, picking 3 other words that are quote unquote like plausible alternatives, right? It's picking words for these alternate choices. And in our case, I think we do, maybe an okay job of that, but probably not great either. So some of the models aren't doing the best job, but these are 5 different kind of individual machine learning problems. And each of them we could talk about like how we would actually break down and fix. I really love to quote unquote. Yeah, I do. I don't want to take responsibility for anything that I'm saying, and so I put them all in quote marks that I'm legally safe. Ugh. So that's kind of a little chat about, and an example specifically of breaking up your machine learning problem into smaller problems. And we've already talked about some of the tools you would use for those smaller problems. So like, for example, identifying interesting sentences. Well, the labeled data you would really need there is a bunch of sentences and then a label on, is this sentence interesting, right? And there are different ways you could get that, right? I use a couple different metrics. One of the big ones is TF-IDF. If you're not familiar, it's a really cool idea that I would actually love to do a stream just on TF-IDF at some point. Maybe for the next local hack day, I'll pitch that and see if Mary bites. But you have to find a way to label which sentences are interesting and which sentences are not interesting. And once you have that data set, then you can plug that into any number of machine learning models. That those are the kinds of things that you actually learn at all the workshops and tutorials that we've talked about. There being a lot of. So, big point number 3 is that you should think about trying to break down the actual thing you want, right? So in my case, it was Duolingo for news articles, and breaking that down into smaller machine learning problems, and realize that you might build a lot of tiny models that actually fit together to do the thing that you want. So we are actually 3 out of 4 are done, and number 4 is where we're thinking about doing some hands-on, which I guess what the heck, we'll go and do the hands-on section. We won't phone it in today, but it might be a little bit of a hassle, so just get ready. But lesson 4, which we have a great segue into, is just the idea of not reinventing the wheel. And I'm going to put a big caveat on this. So there are a lot of tools out there that will do machine learning, quote unquote, for you, right? Google has something called AutoML, where you just give it your data and it will kind of automatically create a model for you that uses that data. There are, of course, lots of libraries. There's libraries like scikit-learn in Python. I know like MATLAB has a lot of machine learning libraries. There's libraries like TensorFlow and PyTorch and all these different things. Lots of cool tools out there. The one big caveat before we kind of dive into them is sometimes it actually is really, really good and helpful to reinvent the wheel to learn, right? I know that one of the first sort of machine learning things that I did, in hindsight, is kind of silly, but the idea was I just wanted to build a model that you could give it a word and it would try to predict, using machine learning, whether or not the word was English or Spanish. Now, think back to point number 1 and be like, I wasn't looking for machine learning, I was looking for a database. But I thought this would be cool to do this, with the machine learning. And so I hand coded my own artificial neural network, my own multi-layer perceptron model, which some folks will be familiar with. And I think a lot of people have that experience of, okay, I want to know how an artificial neural network works, so I'm going to code it up from scratch. And that's actually lovely to learn how an artificial neural network works, right? I think that caveat aside, that you could maybe reinvent the wheel once so you understand how it works, but that you should not continue to reinvent the wheel, right? I did that project once or twice where I kind of hand-coded my own artificial neural network. But then after that, I started using scikit-learn, and I started using, all these packages and all these tools that often are going to be the ones that you're taught about. And so kind of the big thing there is that you should use those pre-built things. In fact, for the example that we just looked at, for yogurt, many of those models that I mentioned, I obviously had to write the code to use them, but the models themselves already existed. For starters, our first model, getting the text out of the article, there is this really cool library called Goose. It's a Python library, and all it does is you give it a URL, and it gets you the main body of text from that URL. It's super cool, super helpful, and it's a library that I recommend. For splitting up the text into sentences, this is something where there are lots of good tools out there. I ended up using this library in Python called Spacey, but there are lots of other libraries. NLTK is a big one that folks will use. I think that scikit-learn is a big library that also has a bunch of sentence tokenizers. For finding interesting sentences and finding interesting words, those were actually ones that I did a little bit of manual work myself. I looked at metrics like TF-IDF, which again, if you're not familiar, it's just a way of finding what words are sort of quote unquote important. There you go, Adam. Another quotation mark. But for those first 2 models, those were just kind of off-the-shelf models that I was able to borrow. And so kind of the thing to throw out here is that you should not be trying to reinvent the wheel. Now, our little hands-on bit that we're going to do, the plan that I had, as I mentioned earlier, and I will mention again, is that I work for Google, and I work specifically on Google Cloud. And so I have a lot of familiarity with all the tools they have. And I think many of them actually are really, really cool. And so one thing that I wanted to walk through was how to use their natural language API. And if you are familiar, there is a platform called Quick Labs, which is actually really, really neat. I will throw Quick Labs on the screen. There we go. Boom. And I for a second will tell you how cool Quick Labs is, and then I'll tell you that we can't use it, or that we probably can't use it. But what it does is it actually will, when you start this lab, it kind of creates this ephemeral Google Cloud account for you, and it basically gives that account infinity money, right? There basically is nothing that you cannot do on that account. And the only catch is that account only exists for 40 minutes because you have this this little timer up here. Here, let me make this. Oh, making the wrong thing big. And it exists for 40 seconds. So Quick Labs is awesome. The only catch is that you need credits, quote unquote credits, to use it. You say this one takes 1 credit. And I had the opportunity to get these credits and just did not request them fast enough, and that is on me. But what we can do is, because all it does is it actually just gives you a little portal to Google Cloud. If you have, where are my windows? If you have or don't have a Google Cloud account, you can sign up for one and get free credits. And if you've signed up, hopefully you still have some free credits to play along with. And I will drop that link in the comments. And again, if you're like, hey, Will, I came to just kind of hear some cool chit chat about machine learning and putting things together, that's totally fine. And feel free just to hang out and watch. No pressure on actually following through with this. But if you'd like to, it could be really cool, and I would encourage you to, but no pressure. Encouragement, but no pressure. So what we're going to do is basically use Quick Labs as our instruction manual, but then do our actual work in kind of a real Google Cloud console. So this is where you can sign up to get 300 free credits. If you are already signed up, you should be able to just click on this console button. I'm not sure what will pop up, but it might actually be the backend for Yogurt. Oh yeah, it's my backend for Yogurt quiz. Look at that. And and look, a little bump in usage when I was playing with it earlier. That's kind of fun. So Adam said he just literally came to Vibe, not even for AI. Not even for just AI. Well, that's good. I'm glad you came to Vibe just for the vibes. And I think anybody that wants to vibe just for the vibes is more than welcome to do so. So this is if you have signed up and gotten your free credits. If you have any problems with this, let me know in the comments and I will help you troubleshoot getting free credits. But if you are all signed up with that, then you should be plopped down into a dashboard that looks like this. It might look a little bit different from mine. But on the whole, it should look pretty similar. You'll have these little pop-ups. You should see maybe your initials or some kind of icon for your profile here, and then the little navigation menu on the upper left. So we are going to walk through this tutorial. In fact, I'll actually take it off screen, but you have the link so you can follow along. You don't necessarily need me, but I am going to do it with you. And this is, just to kind of zoom out for a second, this is us looking at not reinventing the wheel. And if there are tools out there for something, going and using those tools. Because ultimately, if you're building a project with machine learning, it's going to be putting all those individual pieces together that gives you something actually useful. And that's where, where the actual creativity and kind of art of being a computer scientist comes in. So we should be able to, if you have gotten to this point where you're in your Google Cloud platform, you can actually skip down to where it says activate Cloud Shell. This is actually a really cool feature that Google Cloud has. This is me shilling for Google a little bit because this is my baby. This is what I work on. But they give you sort of this free mini computer that you can run commands on. And so this is kind of your own little little free terminal that you can just play around with, and it already has all your Google Cloud tools installed there. So you're just going to click on that button, on the terminal button up in the upper right-hand corner, and it'll pop up down here. Now, once you get to this point, one thing that we usually have you run in these workshops is run the command gcloud auth list. And this just makes sure that everything is authenticated. And this is saying it's requesting to make a GCP API call, and you click authorize. And this just means like, okay, yes, everything is kind of hooked up correctly. There are other commands you can do to trigger the same thing, but I will just plop down the gcloud auth list command in the comments. Oh yeah, I can drop the, I think it's literally cloud.google.com/free, but I will double check that and drop the link if it is correct. Yes, that's the one. Thank you for asking, and there is the link. Awesome. So now that we've actually run a command in our terminal, we are kind of in good shapes to kind of do our next part of this code lab. And the very next step that we're going to be doing is creating an API key. So this is kind of a big concept to throw out there. But when you are using resources that are part of a different service, right? So you have your own computer that's running stuff on it. And if you want to use a library that's just like on your computer, you don't have to do any kind of special authentication dance. But when you are actually making a call to another computer and saying, hey, other computer, do this specific kind of work for me, we usually make your computer authenticate. And one of the ways we do that is with an API key. So this basically just says, I can use this key, and it gives me the authority to go boss that other computer around. But I need this key in order to do it. And so the first big thing that we'll do is create a key to actually use to be able to use our AI service, which has just dawned on me that we're actually, I talked a little bit about natural language and the natural language API. I did not actually thoroughly describe what we're actually doing here. And so I'm going to take a step back and tell you about that. So there are lots of different things that the natural language API from Google can do. But the one that we're going to be using that I think is really cool is the quote unquote analyze entities. I did it again. I quoted and unquoted again. But it is the analyze entities method. And this actually is something that I think would be really cool to use for the project that I showed you earlier, the yogurt project. Because what it does is it extracts entities is just this vocab word we use, but these are things like people, places, and events, right? So what if when I'm generating my quiz, I actually only look for these entities, people, places, or events, and those are always the answers to my questions. I think that actually might make it a better question if the fill in the blank is kind of a specific proper noun, either a person, a place, or an event. So you could say it's either Michelle Obama, Iowa, or the American Revolution, right? These are examples of people, places, and events. And I don't know what it says about me that the first things on the top of my head were Michelle Obama, Iowa, and the American Revolution. I don't know, but that's what popped up for me. So we are going to first run this command, and you should be able to just follow along and copy these commands straight from the natural language API quick start that I posted the link for. If you're still looking for the link for that, let me know and I can drop it in there for you. So we will paste that first command. So what we're doing here is we're just running a gcloud command. Gcloud is kind of our standard command line interface for all of our Google Cloud stuff. And this is just getting the name of our project and storing it in this variable Google Cloud project. So now this is not part of it, but if you typed echo and then you did Google Cloud project, name of our variable, you would get the name of your quiz, or the name of your account, or your project. And for me, that's Yogurt Quiz because I'm just using my same account. Now we're going to create what's called a service account. And we can talk about what that is for a second, but I won't go too in depth because this is not a workshop about Google Cloud. This is a workshop about using AI and pasting different pieces of AI together. So we will hit return on that command. Basically, the upshot is that we, as users, have user accounts, right? If you scroll over here, you can see this is Will Liffert at my Gmail account, and I am a user, and so I get that user account. But we have lots of things that have to do authentication that aren't users, right? And the name that we use to refer to them is services, right? So if you have a server, it might be running a service, and that service might have to go and try to authenticate with other services. And so this is what a service account does, is it just makes kind of this identity that a non-human can use to authenticate. So this command just created a service account for us called my.lang.sa. SA meaning service account. Any questions about service accounts? It's kind of a complicated idea, but it's not one we need to go too in depth in. I'll keep an eye on the chat and see if anybody does have questions. Cool. So now we've created that service account, and this is where we're actually going to create some keys. And so this next command we're going to run, I just realized this editor is probably really small and probably hard to see. So I'm going to, I know there's a setting where you can change the text size. Terminal preferences, text size. Let's make it largest. Oh, perfect. So this is our next command that we're going to run. And so it's another gcloud command. IAM just stands for identity and access management. So it's all the stuff around authentication, which we kind of have to set up when we want to use these extra services. But so we're using service account stuff, and we're creating a key. That's why we're typing keys create. And we're going to store our key in our home directory with the name key.json. We pass it the IAM account, and we use that variable for the cloud project that we set earlier. If we hit return, awesome, we created a key. And if we actually just look inside key.json, so if we type key more key.json, we can see this is our private key. This is kind of looks like gobbledygook to you and I, but the computer can use this to authenticate to things. Then finally, the last command that we're going to run is Google application credentials. We're setting another variable, and we're just setting it equal to the location of our key that we just created. Sweet. So now, this is, you don't need to do this, but if we said echo Google application credentials, we would get out the path to our key, so we can pass that around. Okay, so this was kind of a lot of the auth dance. Let's see, can you drop the quick start command? Oh, the quick start link. Yes, and it's actually called Quick Labs. It's kind of a funny name, but yes, I will drop that link. Thank you for asking for it. Boom. So if you've been able to follow along to this point, then that's great. And we are at make an entity analysis request. It's kind of a section on that page. I can actually pull over this. It's make an entity analysis request. Boom. Uh-oh. Twitch is having errors. It did not post my comment for me. It might be upset that I'm just posting so many links. Oh, no. Okay. It looks like it went through. Sweet. So this is the, oh, that's not what I meant to do. Make an entity analysis request is kind of where we're at. Night, Adam. It was great to see you. Thanks for showing up, man. So charging ahead, we're going to actually get our hands dirty and actually be able to run the commands now. We are going to connect to an instance that normally would have been pre-provisioned for us. Actually, I wonder if we really need a separate instance. I think we could actually do this from our cloud console. Let's see if that's possible. So we're gonna try to run these commands just in our cloud console and not from a separate virtual machine, which I think could be good. I'm gonna run the clear command just to clear out my terminal. And we're going to copy this gcloud command. Now, this is a doozy, so we're going to look at all of it. So gcloud, okay, that just means we're using a gcloud command. ML, Okay, this is good. We know we're using a machine learning or a piece of machine learning tooling. Language means that we're using specific language-specific machine learning tool, right? Shouldn't be crazy. And then we talked about the analyze entities method. So now this is the specific function really that we're calling. And this means that we're going to look for all of those entities, right? A person, a place, or an event inside the sentence. So for us, I can think of a lot of things that I would expect or I would hope that the model would put out as entities, right? Michelangelo Caravaggio, that is an entity that I hope it would pick up on. Italian, we might think of as an entity, right? That's like a quality that someone has, but it's a nationality. It might even say Italy, right? And then the calling of St. Matthew, that's also the name of like of a painting, right? So we're going to hit return, and we're going to store whatever it returns into result.json. Okay, it says the API is not enabled. Yes, you can just hit yes, and this actually might take a second to enable. We can hang out while it enables. Awesome, now we can run that request one more time. Oh, it's taking a second. Okay, we might have to do another kalimba break. Or maybe I could. Maybe we could do a ukulele break instead. I don't know. Let me know in the comments if I should do ukulele or kalimba while we're waiting for our APIs to turn on. Okay, we got some comments. Let's read through our comments. Good night, Adam. Adam has a lecture at 9. Good luck with that. I'm not sure if Adam is saying that I better stay active in the MLH community after like local hack day learn, or he will be angry at him. I'm not sure if that's directed at me. I assume it's directed at me because I feel like last time I kind of disappeared after local hack day. So I'll try to not have myself be so absent in the future. Let's see. Adam and Adam are just having a love fest, and that's awesome. Oh, Kalimba is sending to sleep. Yes, absolutely. Wow, names with 4 letters are powerful. That's what I'm learning. All right, Adam, this is your lullaby to go to sleep. It's just going to be the same song again, so get used to it. Yes, that was from Avatar: The Last Airbender. And, apologies for not being full screen again. But it happens. I will get better. The problem is I don't live stream enough to like have all the beats down, I think I need to hit a critical mass of live streaming often enough that I remember these things. But I promise to get better, I guess is what I'll say. Yes, I do need Hannah as my producer, like always. Always. Adam, I will do more live streams, okay, for you. Okay, coming back to this, hopefully our API should be enabled now. And, oh, it passed. Okay, this is good. We get to have some fun now. So now, I'm going to use Vim, but you can create, I might create a Twitch. I don't know. Adam, let's talk about it offline. I don't know. I'd be interested in creating a Twitch. Let's Vim into result.json. You don't have to use Vim. I know Vim is kind of a funky one, but you could type, if you don't want to use Vim, actually, just use more. Just type out more and then result.json. And then you can make your terminal bigger. And then you can just press the space bar, and that kind of moves you down. In fact, you can also just scroll. So what we have got is a bunch of entities, and a bunch of mentions. Now, we could dive into the specific data structure a little bit, but I think the cool thing is just to look at what it actually picks up, right? So for example, we have the content Michelangelo Caravaggio. We know that it's a proper noun. We know exactly where in the thing it begins, or where the mention begins. We know this person is a painter. We have this mention of Michelangelo Caravaggio, but we know that we're actually mentioning the same thing when we say painter, right? So painter happens later, but we actually know that's still referring to Michelangelo Caravaggio. Yes, Hannah, collab, podcast, thing, Twitch. I'm totally into it, 100%. And then we have some metadata on this person. We know it's a person, and we know that person. We even have their Wikipedia article. Now, another score, or another number that I think is really interesting to throw out and to talk about is the Salience Score. Salience is one of those funny words, but it really just means how important is something to the document it's in, right? So, for example, if I am talking about, like pineapples on pizzas, and I say, hi, my name is Will, and I love pineapple on pizza. I think pineapple on pizza is delicious. The word pineapple has a lot of salience, right? Like, because that document is about pineapple. But I think I said think, because I said I think this is delicious. The word think actually doesn't have a lot of salience, right? The document is not about the word think, or that sentence is not about the word think. And so salience just means how much does this thing really capture the meaning of the whole, is one way of thinking about it. And so in this case, the salience for Michelangelo Caravaggio is 82, which I think is pretty good because Michelangelo Caravaggio is really important in this sentence, right? This is a sentence about a painting, it's about Michelangelo Caravaggio. If we continue to scroll down, we see Italian, and we have a salience score that's pretty low, which I think is good because this is actually not a sentence about Italy, right? It's not a sentence about being Italian. It's not about being Italian, y'all, okay? And we call that a location because it's kind of referring to being of Italy, the location. But it knows that it's not, the sentence is not about Italy. And then finally, we have the calling of Saint Matthew, and we know that that is a proper noun. We're calling that an event, which I think is like an interesting question. Like I would have called it like a thing or an object or like a work or something. But you could maybe think of the painting of that as an event, and it actually refers to, the name of the painting refers to an event, right? It is when St. Matthew was called to do something because it's the calling of St. Matthew. So maybe we let it off the hook for calling that an event because it kind of does seem like an event. And then, of course, the salience is pretty low. And I think that's right, that this sentence is not about the calling of St. Matthew. It's about Michelangelo Caravaggio. So this is a building block, right? This is not a full app. This is not a full product. But hopefully, from talking about this kind of specific use case where we are taking news articles and trying to build these multiple choice questions out of them, hopefully it becomes a little bit more clear what the point of something like this is and how this is a puzzle piece that I actually don't know how to write my own entity recognition system. But I do know how to ask Google to do it, right? And I know how to set up the credentials, and I know how to make the request and get the result. And I could, basically call this for all of my sentences, find whatever the salient thing was, or the most salient word in that sentence was, and make that the thing that I fill in the blank, right? That's kind of the idea of where my brain would go for this. If you have gotten this far and you've actually been able to make this request, congrats, well done, and thank you for following along with me. This is actually kind of the end of the formal content that I had put together for this, and so I will stop screen sharing, as I know everybody likes, and I will hold a few seconds just to kind of for random chit chat or for any questions that anybody has. Not that you necessarily have to have questions, but if there's any burning thoughts or burning questions, then please let me know in the comments. This could be if you actually want to help troubleshooting something specific you're working on, if you want to brainstorm about ideas, or if you have questions about Major League Hacking, Local Hack Day, machine learning, Google, coffee. If you have any coffee questions, I know I told people at the last stream that you should come here if you still have coffee questions. But I will put it out to y'all to hear if anybody has any burning questions. Let's see. I tried to follow Quick Lab. Not Gilgamesh. I'm so glad that you enjoyed it. Yeah, thank you for coming. Mouse058. I tried to follow, but Quick Lab did not let me open a console and run. Interesting. Can I ask, were you trying to run Quick Labs in Quick Labs, or did you try creating your own Google Cloud account? Because I would have liked to have us use Quick Labs, but I did not go and request credits early enough, which is totally on me. But so our workaround was just having people create their own Google Cloud account, which is a little bit different. But you should have been able to create a free account and get free credits with that cloud.google.com/free link. I can send that back out again, but I'm not sure exactly what part of it you got to. If you have more deets, then I could maybe help troubleshoot a little bit more. But hopefully that's helpful. I am also sure that well, first of all, I think it's possible that I will do another live stream on this kind of thing, and I promise that I will actually get Quick Labs credits then. Let's see. I created a Google Cloud, but oh, okay, this is great. Yeah, if you create a Google Cloud account, and maybe I'll screen share again. So we were just using, and I think I glossed over this, so thank you for calling it out. We were just using Quick Labs as kind of our instructions. Because it kind of shows you how to do a cool little lab, but we're not actually linking it up with our Google Cloud account. So if you were able to create and log into a Google Cloud account, probably what it looked like for you was something like this. And the only thing that you needed to get to the point where you can just start running those commands is just come up to the upper right-hand corner, and right here is the Cloud Shell. And then you can use all of the commands from that, just from that page in the Quick Lab in this little terminal. And that was the kind of, I think, maybe the missing piece. And so that if you have the Quick Labs link, so if you have Quick Labs pulled up, then you can just come through here and just literally copy these commands and paste them there to run them. And that's kind of the only kind of only connection between those two you need. Yeah, I kind of skipped over I think I said, oh, you click this button, but I should have made a bigger deal of, yeah, this is the little terminal button that opens that up for you. Yeah, no, I'm so glad that you asked. I'm glad that you're trying to follow along, and hopefully that's able to help you get unstuck. Once you do that, there's just a few steps for creating authentication and then running the command. Yeah, you are very, very welcome. Thank you for paying attention and for asking. Alrighty, friends. Well, if we have any more questions, I'm totally down to hang out a little bit longer and answer them. But if not, I will say thank you all so much for coming. I enjoyed this. Was a little bit more freeform, and we got to talk about some more ideas about how to actually use these things and not just run through a tutorial. So that was a lot of fun for me, and I hope it was useful for you. If you have any other questions, feel free to hit me up on LinkedIn. This is now where I tell people to reach me after live streams, just because it's kind of easy to batch those together. But I would love to hear from you, and I would love to see you again at another live stream event. So thank you so much, and happy hacking, and happy local hack day, and good luck. Take care, everybody.